Good morning, students. I am isolating today in my classroom, so you cannot come to my class, but we can still continue with our work. I will show you or make you the video and then share it with you. Today we are going to do identical complex numbers. Now, you know when the complex number is in rectangular form, that if I want to know what is going to be the value of A and what is the value of B, you will see on the left hand side A corresponds with a 2. So you will be able to say that A is equal to 2, and you will be able to say that the coefficient of I is B, so the value in front of the I is 3. So you will be saying that B is equal to 3. Sometimes it's not as straightforward given as it is in number 1. Sometimes they give it to you where you are going to have more terms, and the main idea is to get your left hand side written in the form A plus BI, and this side as well as C plus DI. Okay, so that is our main aim at the moment. If you are looking at those two terms, you will see that there is a common I that can be taken out. So if let's say we start with the constant -9, but for those two terms, I'm going to take out a positive I. So if I'm taking that out, there will be left in a bracket 3x and then minus 1, the ghost 1 that will be there. That is again equal to the following. Now, if we look at this, there's only one term containing I. So let's say we have plus xi. But these two terms, although there's no common factor, we can at least group them together. So we say 3y minus 10x. So if we have a look this time, our value of A will now be this -9. The value of B will be this bracket 3x minus 1. Our value of D in front of I will be x, and the C value will be both these two terms. So if we are going to look at it like this, I'm just going to show you that the coefficient of I is now x, which should be equal to the coefficient of I again, which is going to be 3x minus 1. And there you have a linear equation, and you can just solve it. So bring the x to this side, take minus 1 over and divide by your 2, and you get x is equal to a half. And then if you have a look at your constant value, like in this case, we can say, but this -9 is in the place of that constant value. So 9 should be equal to, -9, should be equal to 3y minus 10x. But remember, x was calculated already as a half. So if you do this bit, you will find that 10 times a half is minus 5. This minus 5 will be brought over to become plus 5, so it will give us -4. And if we divide by the 3, we get that the y value is a -4 over 3. Okay, so that is where you are going to use identical complex numbers so that you can tell me what is the value of x and y. Then, even if you want to have a look at this, number 3 and number 4, it's the same thing, identical complex numbers. So what you are going to try and do is you will still try and get the left hand side equal to your right hand side. So, first manipulate the left hand side so that you might be able to get the right hand side. So we were taught we are going to multiply the denominator with the conjugate, and whatever we do at the bottom, we need to do the same thing at the top. So if we do this, 6 times 3 is 18. That will give 3j plus 6j will give us a 9j. And then j times j will give us plus j squared. All over 3 times 3 is 9 minus j squared. Now remember, the j squared is also equal to -1. So for this left hand side, we will say then that we actually have -1 there. So 18 minus 1 will give us 17 plus 9j over. This is -1, so minus -1 will actually give us 9 plus 1 to give us 10. But at the moment, the right hand side does this. Okay, so it seems like y could be 17, x could be 10, but then the variable in front of j is a 1, and there it is not. So to get here a -1 in front of j, every single term must be divided with this value, but the negative of it. So if I say, not multiplied, divided, so I will get 17 divide -9. This divide -9 will give me ghost 1 over -10 over 9. So if you look at it now, y minus j over x. Now this is a minus j and a minus j. So now we can say that the y value is -17 over 9 and the x value is going to be -10 over 9. Okay. Then the next one, we are going to say simplify this. So if we do simplify it, we get 8xi plus 2i minus 6i. And then you can see if you can maybe take out the common y. So if we take out the common y, we get 8x plus 2 minus 6. So in this case, we will be getting 8x minus 4. And if you want to multiply it back again, 8xi minus 4i. And they want to know what is the value of x and y. So rather bring this guy over, so it will give you 4 plus 4i equal something, and then 8xi. So if there's i, it means this 8x coefficient must be the same as the coefficient of that I as well. So we will get 4 equal 8x. So 4 over 8 is equal to x, which will also give us a half. But because there's no term in place of y, we could say it's 0 plus. So y will be equal to 0. Okay, so that is to work with identical complex numbers. The next thing we are looking at is we are also going to say solve x while we're giving you like a quadratic trinomial that cannot be factorized. Now before I do that, I just want to have a look at this. Let's say you have negative square root 12. So that negative 12 is actually negative 1 times 12. Okay? So we know that negative 1 is the same as I squared times the 12 still inside the square root. But if we take the square root over the I squared, the square and the root will cancel. So we will have I times the square root of 12. Okay, so that is one way of doing it. Just a little bit of simplification that might be needed in the sum next to us. Now let's see, if we're going to factorize this, we will see that it can't, so we use the quadratic formula, minus b plus minus the b squared minus 4a in the square root over 2a. Then I need to substitute the b value, which is a 2, and I will get 2 squared minus 4 times the a value is 1 and then the C value here is 4. So times the 4, put that in our square root, divide by 2 times the value of A. So now what will happen is we are going to say that we will simplify it further on minus 2 plus minus. Now we will get 4 minus 16 to end up with minus 12 over 2. But now this minus 12 is the same as I12. So we have minus 2 plus or minus square root 12I over 2. Okay, so you can continue factorizing or simplifying it, because square root of 12 can be written as 4 times 3. And the square root of 4 is 2, so you can actually have 2 square root 3I. So if we do it there, we get minus 2 plus minus 2 square root 3I all over 2. And then those 2's can cancel out. So we will end up with negative 1 plus or minus square root 3I. Okay, so for today you do for me the next exercise. The next exercise will be 3.5 on page 68. Okay, so you do for me today 3.5, that whole exercise. Thank you guys. Enjoy your day.